We're now working on the second problem for similar solids. We have two cylinders here. So the first thing that we need to do is find the scale factor of the figure on the left to the figure on the right. Like we said before, because we know they're similar figures, it doesn't matter which piece we start with as long as we use the corresponding piece in the other figure. So for our scale factor, I could use the radius, which would be 21 miles in the left figure compared to 70 miles in the right figure. My miles would cancel, and if I simplified this, I would get 3/10. Since 7 goes into 21 3 times, and it goes into 70 10 times, which would be 3:10 for our ratio. I could have also, or alternatively, used the height, which was 27 miles compared to 90 miles. I would once again get 3/10. Since 9 goes into 27 3 times, and it goes into 90 10 times. So my scale factor is 3:10. Now the ratio of my surface areas. So I have a little bit of a calculation to do here. We have surface area equals 2 pi r squared plus 2 pi r times the height of the solid. So for my smaller cylinder, I have 2 pi times 21 squared plus 2 pi times 21 times the height of my solid, which is 27 miles. So the surface area for my smaller cylinder, when I simplify this, is 2016 pi miles squared. I can leave it in terms of pi. The surface area for my larger cylinder, I have the same formula, 2 pi r squared plus 2 pi r times the height of the entire solid. So I have 2 pi times 70 squared this time. So we are going to have to deal with some larger numbers. Plus 2 pi times 70 times the height of my larger cylinder, which is 90 miles. When I multiply this out and then add the two pieces together, I get 22,400 pi miles squared. So for my ratio, I have 2016 pi miles squared over 22,400 pi miles squared. The pi and my miles squared can be canceled out. When I reduce this, I'm left with 9/100, which we can write as the ratio 9/100. Part C of this problem asks us to calculate the ratio of the volume. The volume of a cylinder is calculated using the formula pi r squared times the height of a solid. So for my smaller cylinder, I have pi times 21 squared times the height of my cylinder, which is 27 miles. Again, don't be afraid of large numbers. We can leave it in terms of pi. We have 11,907 pi miles cubed this time. For my larger cylinder, same formula. Volume equals pi r squared times the height of a solid. The volume equals pi times my radius, which is 70 squared, times the height, which is 90 miles. This time I end up with 441,000 pi miles cubed. So for our ratio, we're going to start out with a fraction of 11,907 pi miles cubed over 441,000 pi miles cubed. Cancel out your pi miles cubed. Simplify that fraction. You're left with 27 over 1,000. You can write as 27 to 1,000 for our ratio. Let's just go back and be very clear that for our scale factor, we were dealing with units. For our surface area, we were dealing with units squared. For our volume, we were dealing with units cubed. So once again, our ratio for our scale factor, we're just going to plug in A to B. Now let's go up and look. To get from 3 to 9, I need to square that number. It also works. 10 squared is 100. So the ratio of my surface areas is going to be A squared to B squared, which makes sense with our units. And then lastly, the ratio of our volumes is 27 can be found by doing 3 cubed. 3 times 3 is 9, times 3 is 27. 10 times 10 is 100, times 10 again is 1,000. So we're just cubing A and B. Good job then.